again, and welcome to another program in the Royal Tutorial Initiative series about physics. And today I want to talk to you about keeping warm in winter. Now, at the moment I'm feeling pretty chilly because Bhutan is blessed with high mountains, and I'm up in the mountains, and it's the beginning of February and the weather is cold. But of course I'm dressed for the cold weather, and I'm going to talk a little bit later about how the clothes we wear in winter can help us to keep warm. But I wonder if you can guess where I am at the moment. I'm actually in a wonderful place. It's a couple of days or one long day's drive from Thimphu, and I've actually come to a place where people have a very good way of keeping warm in winter. And they keep warm by coming to this very special place, the Gasa Hot Springs, Gasa Tsachu. And if we look down below me here, we go from the high mountains with the snow on all the way down to a big tented camp, and we see there the Gasa Hot Springs. And let's say a little bit in a moment about the Gasa Hot Springs. And there are lots and lots and lots of people here, and they're keeping warm in winter in a very special way. It doesn't involve them building bonfires, no electric heaters. They've come to keep warm by getting into the hot water that bubbles up here through the rocks from deep down in the earth. And the water here in the Gasa Hot Springs is actually heated up by the heat that's inside the center of the earth. You probably know the center of the earth is a great ball of liquid iron. It's so hot, it's a great ball of molten iron. And the deeper you go under the surface of the earth, the hotter it gets. And so this water comes from many hundreds of feet below the surface of the earth. It bubbles up and it comes out here into Gasa Hot Springs. Wonderful hot water where you get in, people stay here for hours and hours and hours, soaking up the heat from the hot water from the center of the earth. And you know, there are places in the world, for example New Zealand, where you have hot springs where the water force is so powerful it shoots up in the air to several hundred feet high, a great fountain of nearly boiling water. And in America, in Yellowstone National Park, there's a great geyser, a great fountain of hot water, which comes up at regular intervals. It doesn't go all the time, it comes up at regular intervals, and it's a bit like a clock, and it's called Old Faithful. So here in Bhutan, we're very lucky indeed to have some hot springs, and it's a wonderful way of getting warm. And the water comes from deep inside the earth, so dissolved in the water are all sorts of minerals, all sorts of chemicals, which can be very good for helping with some forms of illness. For example, if you have arthritis or rheumatism, some sort of skin problems can be helped by the chemicals in the hot water which comes from the center of the earth. One thing I should warn you about, though, if you go down to the hot spring baths there, you'll notice a smell, a funny smell of sort of sulphury, a bit like bad eggs occasionally. Now, if you go up here above the hot springs, you can find a place where gases are coming out of the rocks, and these gases are coming from deep in the earth. And I'm told that some people actually go up there and they sniff the gas. Well, I really recommend you don't do that, because the gas that comes out that you can sniff, it smells like rotten eggs, it smells like bad eggs. And it's actually a gas called hydrogen sulfide. And hydrogen sulfide is one of the most poisonous gases that exists. And people who go and sniff it, they say, oh, you go all dizzy and then you faint. Of course you do, because it's poisonous. And if you sniffed it for a little bit longer, you'd drop dead. So I really don't recommend you to go and sniff the gases that come out of the earth up there. However, going down and bathing in the hot springs is a wonderful tonic and a wonderful way of keeping warm in winter. The only problem is, if you happen to live in Thimphu or in Monga, it's a long way to come to Gasa Hot Springs. So in this program, I want to talk about other ways of trying to make sure that you can stay warm in winter. But let's look around the hot springs. Well, late last night I had a wonderful warming experience through a dip in the hot water here at Gasa Tsachu, and the hot pool is really wonderfully hot. And now it's a rather cold morning up here in Gasa. As you can see, there's no sun, it's all cloud. And normally, if it was a sunny day, I'd be sitting here eating my breakfast and I'd be warmed by the sun. And I'd be getting heat from the sun by radiation. But this morning, there isn't any sun. It's all cloudy. So I have to create my own source of radiant heat. And so we've made a bonfire. And so I'm sitting here now in front of a lovely bonfire, and it's very interesting, isn't it? Because this is giving me heat in just the same way that the sun does, through radiation. Now, if we think of conduction and convection, conduction doesn't have anything to do with it, because I'm not touching the hot logs, and there's no wonderful conducting material between me and the fire. So conduction doesn't work. Convection, well, the hot air and the flames from the fire are rising upwards, except when the wind blows and it blows all the hot air and smoke at me. Have you ever noticed how wherever you sit with a bonfire, the wind always changes so that the smoke always blows towards you? Well, if there were no wind, the hot air is just rising. And so I'm not getting hot from the hot air rising. I'm not getting hot from convection. A bonfire makes me feel hot from radiation. And the red hot logs right in the middle of the bonfire radiate a lot of heat, and it comes to me through the air, and I'm sensing radiation. And we're also using the bonfire to dry some towels which we used down at the hot springs last night. And again, they're not on top of the fire. If they were, they'd catch fire. Heat from the bonfire is reaching the towels by the process of radiation. So radiant energy is the main way we get hot from sitting around a wonderful bonfire. And to sit around a bonfire in this nice surroundings of these mountains early in the morning, eating breakfast when all around is cold, wearing warm clothes and getting warmed up by radiation from the bonfire is one of the nice experiences. Much more fun than sitting in a room in Thimphu being warmed up by convection radiators. So behind me you see the excellent new accommodation that has just been built here in Gasa Tsachu. So next winter, when you want to get warm, think about coming here. Well, now, I've often said that physics is really simple. Physics simply tells us about things we know about from experience of living in the world. One thing we know about sitting in front of a bonfire is that if I get too close, it becomes uncomfortably hot. That's pretty obvious. The closer you get, the more heat you're getting from the bonfire by radiation. But physics goes a bit more into it, and it gives us numbers. So what we know about radiant heat coming from the bonfire is that it obeys a law called the inverse square law. And what that actually means is, here it's very comfortable. The heat is not burning my hand. If I halve the distance to the fire, wow, that is far too hot. Halving the distance to the fire increases the amount of heat energy I'm getting by radiation by 4 times. Half the distance, 4 times the energy. Half again, and it'll be 8 times. So the inverse square law tells me the nearer I get, the smaller the distance, the more the heat. If I halve the distance, the heat goes up by 2 squared, 4 times more. If I halve the distance again, it'll go up by 2 squared, 4 times more. So it gets hotter very quickly. If I were to look at a graph of temperature against distance, it would be like that. The nearer I get, the much more quickly the heat energy rises. Conversely, if I double my distance from the fire, the amount of heat energy I'm getting goes down by a factor of 2 squared, 4 times less, doubling the distance, 4 times less heat energy. Now, this is a law which many things obey, but in particular, radiation from a hot source obeys this inverse square law. Halve the distance, 4 times the heat. Double the distance, 1/4 of the heat. 2 squared. If I move 3 times as far away, 3 squared is 9, I'll only get 1/9 as much energy. If I move into 1/3 of the distance, I'll get 9 times, 3 times squared, 9 times more energy. The inverse square law in action, sitting around a bonfire. And we all know it. We all experience it. We all know if the fire's too hot, I move away a bit. So physics is just simple, ordinary, everyday experience of what happens to us in life. I got back safely from Gasa Hot Springs and got to my house here in Pagana Valley, north of Thimphu, to discover snow. So the question of keeping warm in winter is something which is very much in my mind at the moment. One way of helping, I've got a nice cup of hot coffee, and if I put my hands around it, it helps keep my hands warm. But keeping warm in winter is much more than just having a hot cup of tea or a hot cup of coffee. And keeping warm in winter is all about the 3 things that you learn about in school: the way heat energy gets from one place to another, the 3 methods of heat transfer, which are conduction, convection, and radiation. Well, you see me standing in snow because whilst this morning there was lots of snow everywhere, it has melted rather quickly. And all I have to do is just walk this way a little, and you will see that here the snow has all melted and I'm standing in lovely bright sunshine. So this is one opportunity to talk about the way of heat transfer called radiation. Now, radiation is quite a strange way of getting energy from one place to another. I'm getting lots of radiant heat energy, infrared rays, from the sun. And of course, the sun is a very, very, very long way away. The sun is very hot. The sun's outside surface is at a temperature of about 8 million degrees centigrade, and that is about 800,000 times the temperature of boiling water. So the sun is very hot, and yet I can feel the heat energy from the sun here, and the sun, I repeat, is a long, long way away. How does the heat energy get from the sun up there down to me? And it certainly does, because standing here I can feel the warmth of the sun even in winter. Well, between the sun and the earth is absolutely nothing. It's not air, there's absolutely nothing, an empty space, a vacuum. And the energy from the sun manages to travel through this vacuum to reach us here on the earth, to warm me up and to melt the snow. And the way the energy gets from the sun to the earth is by a way called radiation. And radiant heat energy can travel through empty space. And how does it do it? It does it because radiant heat energy is a wave. It's an electromagnetic wave. It's a part of the electromagnetic spectrum called infrared waves. And electromagnetic waves can travel through empty space, can travel through a vacuum. Electromagnetic waves are the same sort of waves that bring us television and radio. And as you know, radio waves can travel through empty space because with radio telescopes we can listen to radio signals coming from distant galaxies. So I stand here in the sun. The snow all around me has melted because of radiant heat energy from the sun falling on the snow. I can feel the warmth of the sun. Now, there's something rather important about radiant energy. You notice I'm wearing a very dark grey go, and the sleeves are white. The snow is white. The ground is brown. Shiny things reflect radiant energy. So, if I were to put some silver foil on the ground here, you'd find that the snow underneath it did not melt. It would remain there because it reflects the radiant energy from the sun. I think we might even get a piece of silver foil and demonstrate. Well, here's some kitchen foil which you can buy in Thimphu. And if I tear off a piece, then you can see it's very shiny and it reflects the rays of the sun. It reflects the light rays, but it also reflects the infrared waves. And if I were to put this over some snow there and hold it down with a bit of wood so that it doesn't blow away, then if we came back in a while, when the sun has moved round, we would find that the snow underneath the silver foil had not melted when all the snow around had. Why? Because the silver foil reflects the infrared rays from the sun back out into the air. So therefore, they do not warm the sun. Silver, shiny materials of any sort, reflect infrared rays. Dark materials, dark colours, absorb infrared rays. So if we look at my Go, it's a beautiful sunny day. The air is quite cold, but because my Go is dark, it absorbs the infrared rays very well, and I feel quite warm. The sleeves, on the other hand, being white, they reflect the infrared rays. So if it's a cold day, but sunny, I'll keep warm by wearing dark clothes to absorb the heat energy from the sun, to absorb the radiation from the sun. Remember, shiny things, light-colored things reflect the radiant energy, dark things absorb it. I get warm because the sun is very, very hot, much hotter than my body. What about nighttime? If there were no sun, if it were nighttime, then I am warm, but there isn't a sun to give me energy. What I do then, and this is a very interesting point, you know, emergencies, disasters in Bhutan. It can be very, very cold up in the mountains. Every day is not always sunny. Sometimes it's cloudy, sometimes it's nighttime. The danger of dying from cold is very great. For example, if there were an earthquake and the houses fall down and you have to stay outside and you're up a mountain, it's cold, it's cloudy, or it's nighttime, dying of cold is a big hazard. So what we have, and I have these hanging up by my front door in my house, ready for any emergency, thinking ahead, preparing for possible emergencies is a good thing, even though I'm aware that to prepare for emergencies might be a bit inauspicious. Nevertheless, it's actually quite a good idea. You can buy these Polar Shield emergency blanket. Now, if you think of a blanket to keep you warm, you think of something soft and cuddly. All this polar emergency blanket is a sheet of aluminium foil. It's a bit thicker than kitchen foil to make it more durable, but all it is a sheet of aluminized plastic. In other words, it's aluminium foil but with a plastic coating. Now, you may say to yourself, that's so thin, that's not going to keep you warm. But the thing is this: if you are stuck outside on a cold night and you wrap yourself in this blanket, what happens is the heat from your body, which usually would go off into the air, the heat from your body, the radiant heat, is reflected back to your body by this shiny surface. I'll repeat that. The radiant heat from your body is reflected back to your body by this shiny surface, and this reduces the heat loss from your body, and therefore you stay warm. So a thin bit of aluminium like this, and if you don't have a proper emergency blanket but do have some aluminium foil at home, remember, just wrap yourself round with aluminium foil, it'll do the same thing. So this keeps your body warm even though it might be nighttime and very cold outside. So emergency blankets are very useful. You can also use them, you know, if people are trekking up in the mountains and they collapse or become ill. You can wrap them in this thin aluminium sheet, and that will help keep their body warm, because dying of cold is one of the biggest dangers up in the mountains. So the old emergency blanket illustrates the fact that radiant heat energy, infrared rays, are reflected by shiny surfaces. They're reflected by light-coloured white surfaces, and they are absorbed by dark surfaces. I feel warm, and I can distinctly feel warm in the sun here, as opposed to my white sleeves, which feel cool. Next time you've got a dark go on, stand in the sun for a few minutes, and you feel warmth and cool. A very direct illustration. White reflects radiant energy, black absorbs it. Well, you know, one of the important things in winter in Bhutan is trying to keep warm in the house. And one way we can do so is by means of an electric fire. And if you have a normal 1-bar electric fire, like this, then you're getting heat energy from that fire in exactly the same way that we get heat energy from the sun. You're getting heat energy by radiation, by radiant energy, infrared waves coming from the hot element of the electric fire to you to keep you warm. So radiant heat energy, that's how a 1-bar electric fire works. But also, you know, anything very hot is giving out radiant heat energy. A Bakari. If you have a Bakari, and let's find a Bakari, and I'll talk about how you get heat energy from the Bakari. And as you see now, all the snow around here has melted. You notice I've still got my little experiment there, and if we come back a bit later, we'll discover the snow is still there under the silver foil when it's melted all around it. Let's hope. Let's go and have a little look at my house and see how I try to keep my house warm in winter. So, just before we go inside my house, let's quickly pop down. About 15 minutes ago, I put the silver foil over the snow, and you'll see now that the snow has melted around the silver foil. And I said that under the silver foil it had not melted. So let us see whether I'm right. I'm going to move the silver foil, and there should be still snow underneath it. So let's experiment. And there we are, is a beautiful square little patch of unmelted snow. Why has it not melted? Because the silver foil reflected the radiant heat energy, the infrared rays which come from the sun, and so it stayed cold underneath here. So, it's just like putting a blanket above my ceiling, and that reduces heat loss from my warm room. It reduces heat loss by reducing heat loss through conduction. So we've talked about radiation. I'm now going to talk a little bit about conduction. The glass wool insulating layer above my ceiling reduces heat loss by conduction.